Good evening. This is N7GES. Welcome to the NCARC Tech Net. We try to cover topics involving amateur radio, technical topics, both from a hamlet perspective and to more advanced topics. All stations with appropriate band privileges are certainly welcome to check in and ask questions or provide information. You can also join us via Echolink at W0UPS W0UPS-R, and also we have a YouTube channel which we're currently streaming to, so you can copy us live at NCARC YouTube channel. We welcome all views and opinions, and just ask respect for other people's viewpoints and comments. In case of any difficulties with the repeater, we'll reconvene on 145.115 repeater, and hopefully just continue without too much bump in the road that way. We'll start by taking some check-ins. Who is out there this evening that would like to join us? N7GES Net Control.
Good evening, Kevin and Annette. This is Whiskey Zero Delta Zulu W0DDZ Baby 3
via Echolink Mobile.
Good evening, Kevin and Annette. NP4 AI Direct. Sitting and listening.
This is November 0, November, Yankee, Bart and Evans. Good to hear you, Kevin.
Okay, welcome to N0NYY, NP4AI. Brad, it's so good to hear from you, and hope things are going well. Glad you joined us. K0ABK and W0DDZ. Thanks all for being there. Others, please?
This is Kilo Echo Zero, Lima Charlie Kilo, KE0LCK, the other Mike from Windsor.
This is Whiskey Zero, Romeo Delta Charlie, Rob, around Owl Canyon.
Okay. I heard KE0LCK and W0RDC. There was a double other station. Why don't you come again, please?
KE0QPC, Arlen, Fort Collins.
Okay, KE0QPC. Is it Arlen or Art?
Arlen.
Okay, very good. Thank you for checking in, and welcome, Arlen. Anybody else this evening?
This is Kilo Zero Lima Alpha Oscar with Kilo Zero Papa Romeo Bravo, Phil and Luann in Loveland.
This is November 0, Echo Mike Papa, Greg, Fort Collins.
Thanks for not checking me in, Greg. This is Kilo Zero Delta Bravo Echo Debbie in Fort Collins.
Well, I'm sure, Debbie, that he wanted to let you have your own chance there, so... But anyway, thank you for going ahead and taking that. K0DBE, Debbie, welcome. Also, N0EMP, K0PRB, K0LAO. And there was another double. Anybody I missed, come again, please.
Yeah, Kevin, this is Whiskey Zero Alpha Sierra Papa. I had that bad power connection to my radio again. Terry in Berthoud.
Okay, W0ASP. Welcome, Terry. Thank you. Anybody else, please?
Kilo Echo 0 November Papa India. John in Fort Collins.
Okay. Welcome, John. KE0NPI. There was another double. Come again, please, the other station.
Here's me, Kevin. Kilo Delta Zero Tango Yankee Uniform, Joe in Loveland.
Okay, welcome, Joe. KD0TYU. Anybody else, please?
This is November 0 Quebec X-Ray Quebec, Jean and Evans.
Kilo Lima 2 Quebec Oscar KL2QO, Dusty in Nawa.
Okay, welcome to N0QXQ, Gene, KL2QO, Dusty. Thank you very much. Anybody else before we start our topic? And if you don't happen to check in, you're still welcome to contribute. It's just nice to kind of know who's out there before we begin, and also know that we've got plenty of listeners and plenty of people to contribute. Anybody else want to check in before we start in?
KB0SCX, George and Berthoud.
Okay, welcome, George. KB0, rewrote that one wrong. KB0SCX. Thank you for checking in this evening. Okay, let's begin here. Does anybody have questions before we begin with the topic? Okay. The topic of feed line, what to use and why, came up some time back. So let's talk about that. There are a lot of varieties of feed line. Certainly coax is the most common, but there are others as well. And there are people that prefer one type over another. There are certain types that certainly will only work in certain situations and will work better in than others. So lots of possibilities of things to discuss here. And we're really starting with an open-ended question here. But what would anybody like to begin our discussion, and with what comments? Or maybe I should say, does anybody have questions about feed line that they'd like to begin with here?
Kevin, this is KD0TYU. I'm curious what you mean by feed line. You talking the difference as far as like LM400 and Davis Berryflex? Are you talking about the difference between ladder line and coax?
We're talking all of the above. There are a lot of different feed lines that people have that they can use, and it was suggested that we just chat about what feed lines might be best for certain applications. So all of the above that you mentioned are certainly possibilities. Does anybody have feed line questions?
Kilo.
Kilo, go.
Dusty here in Niwot. I have a question about what you guys use when you're setting up a repeater, specifically a UHF repeater. I know, and I've heard a lot of people use hardline, and that's the extent of what I have. I was going to say no, but I'm going to say have heard.
Okay. Would anybody like to address that? What kind of feed lines for use for repeaters?
N0 EMP.
EMP, go ahead.
Stand by one. I've got another receiver in the background I got to turn off.
What's the matter, Greg? You don't want to deal with the echo? I don't blame you. Go ahead when you're ready.
Yeah, it was turning me a little bit nuts there. James would be the perfect one to speak to this. Unfortunately, he's out of town. So I can speak from having been on the sites. We use hardline on our repeater sites, and apparently one of the reasons for that is in a repeater you normally have one feed line that's carrying transmit power up the tower and receive down the same cable at the same time. And in the braided coaxes, like the LMRs and RGs, the different braided stuff, there can be an intermodulation that occurs apparently. I don't know a lot of detail on that. The other issue is loss, and typically our feed line runs on the repeater towers are all more than 50 feet long. Some of them are over 100 feet long, and especially at UHF, there's less loss in the large diameter feed lines than there is in the smaller coaxes. So some of our sites have half-inch feed line, some of our sites have hard line, and some of our sites have 1-inch hard line. I don't know if anyone else has some more detail on that or not. N0 EMP.
Anybody else want to add to that? Repeater feed line preferences.
80TYU.
TYU, go ahead. TYU, go ahead.
80TYU.
Yeah, TYU, go ahead.
Yeah, the only thing I can add to that is that you wouldn't want to use hardline in your house unless you got a lot of money. This stuff is very expensive. Greg, you remember what we got that stuff for per foot? I know that James got a deal, but I remember he telling us what it would cost if we bought it someplace else. Do you remember what that was?
I think we got some 7/8 hard line, and it was less than $2 a foot, and that was a deal.
Yeah, I'd heard that it could be up to $5 to $10 a foot, so it depends on what you're doing. But we use 7/8 hardline, I think, is what we've got up there now. So it's not something you probably want to run in your house, but it definitely it does work well.
Okay, very good. Other questions about feedline? Suggestions, questions? We've got a lot of different types. We have home users, we have commercial users to some degree. We have distant, not only repeater users, but long runs for antennas. We also have a lot of different bands and frequency ranges that we use, and different antennas requiring different types of feed line. Lots of different areas that we could get either questions or suggestions about here.
Well, it's Katie's at TYU again.
Go ahead, Joe.
Yeah, I mentioned, I did a lot of this stuff the other day, and I did a lot of research on different types of coax to use for the house, for UHF, VHF, and HF, and actually James actually helped me a lot. He says use the Davis-Berry Flex. It's basically the same thing as the LM400, except it's not as tough to work with. It's a little bit more flexible, and it can be buried. That's another thing if you're interested in doing that. So pretty much I use that for everything that's here, UHF, VHF, and HF. It doesn't make any difference. And I use that, and that's what I like. The LM400 is a very good cable. I like it, but it's really tough to work with if you've got to make any turns or anything. So there are some advantages in this Davis-Berry Flex.
Use it also for VHF and UHF?
Kevin, somebody doubled with you. Go ahead. I didn't get all that.
Sorry, I just asked, did I understand you correctly that you use it for both VHF and UHF?
That is correct. The only thing I've got is my experimental jet stream out here is just running the old 8X just because I wanted to see how well it worked. But, yeah, I use it for pretty much everything.
Okay. Now, the other station, please. Come again.
W0ASP. I had a question about that Berry Flex because I have used the LMR series cables with the Delta Bravo suffix, which is direct burial, and those LMR cables have a sticky substance in the braid of the cable, which if the jacket of the cable is nicked and water gets into the braid, it won't penetrate very far. Is the Davis-Berry Flex have the same feature?
Good question. I think it does. It's equivalent to 9913, but I have had it out here for we set that hex beam and the rest of the stuff like 5 or 6 years, and I was out there a couple days ago, and I looked at it, and I see no wear at all, and some of it's buried, some of it's not. There is no moisture that gets in it at all. It's a very, very good cable. It's if you get lucky, you can get it for 90 cents a foot, but it's normally about $1.25.
Well, Joe, when you say it's similar to 9913, that makes me shudder, because the 9913 has this semi-air dielectric, which will wick water for miles if the water gets into the dielectric. And I go in some today how I know that. But the 9913 is very, very, very susceptible to water penetration.
This is absolutely not, because I've looked at it, and we've had rainstorms and things. It's been buried under the snow. Absolutely nothing has hurt this thing at all. I have the same connection that when we actually installed the thing years ago. So this does not do it. So I'm using the 9913 only because that's what they said that it's like, but it's more like a flexible LM400.
Okay, Joe. Yeah, like could mean many things. For example, perhaps its loss characteristics are similar to 9913.
RDC.
Okay, let me just see here. Did that sort of answer your question, Terry? We're probably looking for a bit more info there, and I will get to RDC in a second.
Yeah, thanks, Kevin and Joe. Kevin, move on, please.
Okay, very good. RDC, go ahead.
Okay, this is W0RDC, Rob, and I was just curious. Now, you've been talking about a different type of feed line. I don't recognize the designator, the number of the ID, whatever, such as an RG8U or RG58U, and the differences. How does that compare there, this W0RDC?
Okay, let me just clarify your question. You're wanting to know about the actual designator numbers and what that denotes for various coax types. Is that correct?
Well, yeah, I didn't copy down the numbers that the previous gentlemen were discussing, and I don't recall the calls or the names, darn it. I was busy looking up this, or posing the question. Anyway, whatever they were talking about for their feed line, and compare that to either the RG8U and the RG58U.
Breakity broke, please.
Go ahead, Dave.
W0LEV here. Yeah, if you have a copy of the ARRL handbook, all of that is in the handbook, and I think every amateur station should have a copy of that handbook. It's in the handbook. 9913 is a very standard cable, and it's listed on all of the charts in the handbook. W0LEV. It's also online at a number of references.
Okay. And maybe just to summarize a bit, if this will help, Rob, there are different impedances in coax. There are also different grades and sizes of coax. There are different types of material both inside and in the insulator in coax. What we were talking about are things that are used in a similar way to, say, your RG8, but have better internal and especially waterproofing qualities. As Dave said, you can look up a lot more details in the handbook or online. But does that give you some idea of what we were dealing with?
Yeah, I'm listening. I'm learning. Still got questions. Comparing. It's all good there, Kevin. I'll just listen here for a while. W0RDC.
Katie Zoo TYU, maybe we can help him out a little bit more.
Okay, Rob, don't hesitate to jump in and ask more questions. TYU, go ahead.
Rob, what was your question? You're looking at it. We call it LM400, but it's actually LMR 400. But what is your question? What are you comparing this to? The RG like 8? You're saying that?
Yeah, kind of, sort of. Oh, yeah, actually. The LMR 400, we talk about that compare that to RG8U, and as far as its makeup there, I mean, I guess that the RG8U is 11 gauge. I believe it's stranded. I'm not sure. Is the LMR, how's that compared there?
N0WIQ with a comment.
Okay, Carrie, hold on just a second. Let me come back to you. Would somebody like to specifically just chat about those two cable types, LMR 400 and RG8 for starters anyway?
N0EMP.
Start off, and anybody can pick it up. The reason I went with either the LM400 or the Davis Berryflex, which is somewhat similar to the same cables, is if you're running the stuff inside the house, you could care less, okay, other than you have some line loss and things like that. But if you're going to run 50 to 100 feet, with the LM400s, the Davis Berryflexes, and things like that, the higher quality cable, you have less loss per 50 and 100 feet that's going out there, dB loss, okay? Let this drop for a minute. I'm looking at the chart right now, and it looks like if we went 50 feet with and let's say an RG8, we'd lose 1.3. Okay, with an LM400, you lose 0.9, and that's quite a bit when you're considering you're only pushing whatever out that thing, but you actually lose that much. And so that would be one reason why you want to go the more expensive cable. The other thing is that the thing sits outside. I don't know what the good characteristics of RG8, and somebody else could help me know that, but I do know what they are for the 400 and the Berryflex stuff, and they're very, very good. They sit out there for a long time and really cause no trouble. So if anybody else wants to kick it off, please help me.
Yeah, EMP, go ahead.
Yeah, LMR, Lima Mary Robert, that's a brand name for a company called Times Microwave, and their LMR 400 series of cables is basically 0.4 inches or 0.405, which is what the RG8 is, and their website calls it a drop-in replacement for RG8 and 9913. But as far as all the specifics of its construction, that's on their website. If you just Google LMR 400, it'll come up. And then there's LMR 240, which is quarter inch, and LMR 600, which I've never worked with, but I'm going to assume it's 0.6 inch diameter. And in the LMR 400, they have different types of jacket, and but it looks like it's a solid center conductor and an aluminum tape over the insulation, and then an aluminum or copper, a tinned copper jacket over that, a braid, and a foam polyethylene dielectric.
W0LEV once again.
Okay, LEV, go ahead.
Yeah, I might comment the main distinction or thing to be considered in different coax size, since we're all talking 50 ohm coax, not the cable TV stuff at 73, 75 ohms, is loss per unit length. Becomes very important the higher in frequency you go. Of course, 450 here, it is quite important. The secondary consideration is where it will be used, buried, exposed to the sun, whatever, and of course that includes susceptibility to moisture and water. But the big one is loss per unit length as a function of frequency, W0LEV.
For DC?
Yep, I was just going to ask you, Rob, if that helped you. Go ahead.
Well, yeah, we got it going in a particular direction here. And Joe, thank you for the comparisons. Appreciate it. And W0LEV, yeah, very, very good. I appreciate it, and hopefully the conversation can continue in the direction. W0RDC.
IQ.
Yep, I was just headed for you next. This is N7GES with the NCARC Tech Net. Go ahead, Carrie.
In terms of coax cable and or the power you are transmitting with causes different potentials depending on the power level. So the insulation in a coax, as well as the spacing between the shield and the center conductor, will tolerate the potential differences depending on what you're trying to use for power out. So between the power out and the variation in impedance due to frequency are two major considerations, and also the loss of power through the cable. So we've covered most everything you need to know about a feed line. So I'll just leave it at that, but it's one of those things. More power, more potential differences, more distance between the shield and the center conductor, which can be shortened by the dielectric.
Yeah, impedance does not vary as a function of frequency within reason. W0LEV.
Okay, very good. Thank you, Carrie. Thank you, Dave. Other questions, specifically questions at this point?
SCX.
SCX, go ahead.
When you have feed lines that are quote-unquote equivalent, can they be used with the same connectors? You have to get different connectors depending on the size of the coax?
The IQ again?
Okay, first let me ask you, George, are you talking, for example, RG8 and RG58 or other differences?
Well, RG8, RG58. Actually, I was thinking of LMR 400 versus the Davis Berry Flex, where they're roughly the same size.
Okay. Gary, I will come back to you in a second, I promise. Yeah, I guess I would say no. And somebody can correct me if I'm wrong. The general coax UHF connector, which is what we know of as the standard radio connector, the PL259, generally I believe will accept any of those sizes with an adapter for smaller cables like the RG58, and I believe the others are pretty much interchangeable. Am I correct on that, Dave? Are there any other considerations one has to make for just using a standard UHF connector on those different cables?
Yeah, unfortunately the UHF connector, PL259, SO239, has become somewhat of a standard. I should point out that connector is not impedance controlled. It is not a good connector to use much at and above 50 megahertz. Especially when we get to 450, I have measured plenty of losses across different dielectrics within the PL259. Type N is a much better connector. BNCs are good for inside application and patching around the lab. Everything 100 watts on down I have in my shack. I plug in a UHF to BNC converter and use BNCs. Yet when it comes to higher power, like the output of the AL82 on HF, yeah, everything's SO239, PL259. But they're not a good connector for 450 at all. W0LEV.
Okay. So I do want to come back to you on that as well. But yes, so same connector, most of those cables, except an adapter for the smaller sizes. Carrie, you had a comment.
Well, Kevin, my major comment pretty much parrots what you said about adapters, except the RF connector, the PL259 and SO239, like you said, are UHF connectors. But above, well, Dave said above 50 megahertz, they fall apart as far as being consistent impedance match. So they do cause a loss in that respect. And also, but there's usually a way to adapt from one connector to another somewhere along the line. Of course, each connector adds a discontinuity of a minor amount to the whole cable, so to speak. So you want to keep connectors to a minimum no matter what you do.
Okay. Thank you. SCX, George, does that help with your question?
Yes, it does. Thank you. KB0SCX.
Okay, very good. Okay, so Dave, I'd like to come back to you. Every radio that we get for amateur radio, for the most part, has UHF connectors. Some radios do have N connectors specifically for UHF, but not most. Most have PL250. A lot of them have PL259. In that case, I would say we're stuck with those connectors. using adapters and things I would think would not help in that situation. Is that right?
Well, like Kerry pointed out, every bump in the cable is a possible impedance bump and can introduce things you don't want. However, a properly built, properly designed and manufactured adapter is pretty good. The problem with the UHF, which, yeah, we're stuck with, the geometry is not the same, and most importantly, the dielectric, anywhere from phenolic to Teflon, is variable depending upon where you get it, who you get it, where it's manufactured, so on and so forth. That dielectric changes the geometry, which is not adjusted for to maintain a 50 ohm impedance. Yeah, we're stuck with it. Most of the radios I have that cover through L-band braking at 450, they use type N's. Yeah, we're stuck with it. I think really the issue is amateurs are not familiar with type N's, SMAs, BNCs, so on and so forth. It's a hangover from the old days. Heaven knows Collins even used RCA connectors on occasion, which are totally off the wall as far as impedance is concerned. So, yeah, we're stuck with them. But any good radio, 450 on up, will have type N's. W0LEV.
Okay, so really using an adapter in that situation would really not benefit us at all, correct?
That depends on how you cable your shack. Anything I have, if it's type N, I maintain a type N through the cabling. If it's a UHF, I put an adapter in, UHF to BNC, and use BNC for 100 watts on down. The adapter won't hurt you that much, but type in the UHF, that's something ought to be avoided. W0LEV.
WIQ.
WIQ.
Well, the situation is, like Dave said, an impedance bump is caused by a connector in most cases. Even type N's, although type N's are well defined as a 50 ohm feed through, so to speak, so the impedance bump is less than it would be with a UHF connector, especially above 50 megahertz. So, I mean, that's the whole thing. Every impedance bump causes standing waves. Standing waves cause power dissipation in the power amplifier. That is not defined by the design of the power amplifier. So it could get bad enough to blow up the amplifier. That's all I'm going to say.
EMP.
Okay, EMP.
Yeah, I think some context is important here. If you are running 5 or 10 watts out of a mobile into the repeater, it's not going to matter. If you have a mobile rig on 2 meters and you're running simplex to your buddy and his mobile rig on 2 meters FM simplex while you're out four-wheeling, it's not going to matter. If you're doing extremely weak signal work, especially at 70 centimeters, but then above into 900 megahertz, 1.2 gigs, and you're really trying to dig a signal out of the noise, then it's going to matter. So if you're like 80% of the hams out there that are running repeaters and 20 watts, you're not going to notice a difference. It's not going to It's not going to matter at all. You could use 75 ohm TV cable and F connectors, and you'd never know the difference. And 0 EMP.
I find that a little surprising. You know, we've been warned so much for, you know, on VHF and UHF to be so careful, not necessarily to run the RG8 for normal FM usage. And you're saying that we're really not going to know much difference?
Yep, for FM it really doesn't make squat difference. I spent too much time weak signaling and move outs. W0LED.
Yeah, if you're running through a repeater or you're running power, if you're dealing routinely with S9 or better signals, there's no need to fret about what connectors you're using or what your cable loss is. You know, if you've got 20 feet of cable in your vehicle or 50 feet going onto your roof, and you're dealing with S9 signals in the type of communication that you do, don't sweat it. Like I said, if you're trying to work out the real weak signal stuff, then you got to start worrying about every little bump. Or on the other end of things, if you're running a kilowatt and you're trying to get every watt of power into the antenna, again at UHF, then you're going to worry there as well, and you might have to worry about damage if you have an impedance pump. But if you're running, you know, 10, 20, 50, 100 watts even, and you're working repeaters and working FM simplex, and you're getting an S9 from everybody you talk to, and you're an S9 or better to everybody you're talking to, you're good to go. And 0 EMP.
VIQ with another comment.
Okay, stand by a minute, WIQ. Okay, so this is very interesting to me because this kind of is not what I remember hearing at all. But that's fine. I can go with that. I want to first ask if there are any other questions that all of this pressed dialogue has brought up. We've covered a lot of things here. Any other questions?
W0ASP with a question.
Okay, ASP, go ahead.
What is so bad about PL259 to N adapters? Because I use them liberally.
Not much, Terry. As long as they don't come from China with undefined dielectrics. I use them too, everywhere. W0LEV.
Okay, Dave, I heard you admonish PL259 to N-type connectors, but were in favor of PL259 to BNC. I use both with abandon.
Okay, to clarify, that was mixing type N to UHF. Why make something good worse? But again, on FM, it doesn't make squat difference. In a different game. FM, it really doesn't.
Okay, thank you. Question answered. W0 ASP back to net.
Okay. This is N7GES with the Tech Net. We're talking feed lines this evening. We've gotten into connectors. We've gotten into the difficulty of the PL259 quote-unquote UHF connector really not being all that well suited for UHF, but it is what we're stuck with. in a lot of cases. So we make good use of it as best we can. Other feed line questions at this point? Okay. WIQ, I believe you had another comment.
Now, one of the major considerations when you're building a radio for an amateur, first, the amateur radio operator is doing the amateur radio within his own personal budget. Therefore, if you use the UHF connectors, PL259, and anyway, they are cheaper than the N connectors. So, if you have to have a radio with more than one connector, you want the cheapest connector to make the radio cost less. Things like that. So, if you want optimum performance, you pay a little more for it. That includes the connectors, the cable, the radio, anything. The higher grades of the performance, the more it's going to cost.
Okay, very good. Let's see. We have talked about coax. We've not talked much about, I guess, window line. And I guess I don't believe that is considered hard line. Is that correct? And when do people use window line? Short of, I know sometimes it is used as a radiating part of an antenna. But when would you use window type line in an antenna situation over coax? So there's two questions there. Window line is not hard line, true or false, and when would a person use window line over standard coax type connectors? Anybody want to tackle those?
Well, when no other takers, I'll take it.
Okay, go ahead, LEV.
Yeah, W0LEV, and this might be my last contribution since my burger is done. Coax serves unbalanced sources and loads. If you have a balun at the feed point of the antenna being a dipole, for instance, or a dipole style feed to a Yagi, is a differential source and load. The balun converts that to common mode circuitry. Coax is appropriate. Window line, parallel line, is a balanced transmission line, unlike coax, which is unbalanced. There's no need for a balun if you feed your dipole or dipole-like feed with open wire, i.e. window line, because it in itself is a balanced transmission line. It carries its own return. The loss is much, much less than coax. As a matter of fact, even up into the 400 megahertz region, loss per 100 feet is still less than a dB, properly deployed. However, somewhere along the line, since all our transmitters and receivers are single-ended, common mode, coaxial type inputs and outputs, we need to go from the differential source load of the balance line to the common mode source load of the transmitter receiver. That requires a balun, and I'm not talking transformer, I'm talking a one-to-one, either current balun or common mode choke. Differential line, open wire line used to be very common until coax came onto the field. Very, very different. They both are transmission lines. They both accomplish the same purpose. In theory, they do not radiate. They do not collect common mode energy. They do, but that's typically taken out either in the balun or the common mode choke, wherever you place it. Old-timers, if they're using open line, like to use multiple common mode chokes along the distribution of the line. My HF system here is a combination, short combination window line and mostly parallel line across the back of the garage with number 4, number 6 ground wire. I do that for low loss and frequency diversity. I don't have to worry about SWR in the line. As such, it's inherent in the design of what I use, 250 ohm or 150 foot wires connected to the open wire feeders into the shack. I hit it with the common mode choke into a dual T matching network. The output of that also has common mode choke. From there on, it's all coax. I don't have more than 6-8 feet of coax. Enough said. Very different type of transmission line, but they both accomplish the same thing in a different way. W0LEV.
Okay. Further questions from anybody at this point? This is N7GES and the NCARC Tech Net.
SCX with a comment.
SCX, go ahead, George.
The problem with window line or with balanced lines is supposedly you have to be careful about the environment you run them in, and you can't run them next to metal and so forth.
That's correct. You want most of the fields to close between the two conductors. If you pace it against a big metal piece, the fields will close onto that metal. That's not what you want. That's correct.
On QEX a few months ago. If you look up W6 NBC, he's got an article in which he puts 450 ohm ladder line in rubber tubes, plumbing insulation, and routes it around without having trouble.
Okay, we have
can you do that, but I would like to see quantitative measurements. That's not what you want to do with the parallel line. He is not presenting quantitative measurements, just hearsay. Sorry.
KB0 SCX, back to net.
Okay, everybody stand by, please. We have had 2 completely long doubles. Please do remember, folks, to give your call, your suffix of your call. Let me recognize you so we don't have doubles here. I did want to hear the remainder of what George had to say that got covered. And then, Dave, I think then I'll come back to you. W6NVC article. That was using window line specifically, and what was the point there?
The point was that by putting the window line in a rubber tube, you could route it around corners and next to metal and so forth without the having bad impact.
W0LEV.
Yeah, LEV, go ahead. You had made two comments. You had commented about the problem with what window line was next to. I did not catch most of that because I was listening to George at the same time, and you also made some comment about the article and the findings there. You want to run over that once more?
Yeah, sorry, I'm going in on 7.5. Correct. Window line or open wire transmission line, parallel line should not be placed close to metal objects. The whole idea of window line or parallel line is that the fields close between the two inductors. If you place it close to metal, much of the fields will close from each conductor to the metal, which is not the philosophy of differential line, window line, parallel line. The comment as to doesn't make any difference, I would like to see real data, not hearsay. You can make anything work. For instance, when I was in the apartment, I loaded up on the third floor, I loaded up the downspout. Didn't work well. The downspout worked all right, just we had too much noise. You can make anything work with a matching network, aka antenna tuner. I want to see real honest-to-goodness vector impedance measurements, which the guy did not supply. W0LEV. Want to see the data.
KD0TYU with a question.
TYU, go ahead.
Thanks, Kevin. What is window line? I've never heard of that. I guess maybe I'm I'm thinking something else.
Yeah, it's a standard product. Ham radio outlet sells it. Most amateur radio outlets sell it. It's a parallel transmission line, parallel conductor transmission line, differential transmission line. Rather than using solid dielectrics between the two wire conductors, they window it. They cut windows out of the solid dielectric between the two conductors. Roughly, the conductors are an inch apart. Number one, it reduces wind loading. Number two, it reduces the effect of the dielectric, which is minimal on the impedance of the window line. W0LEV.
K0PRB.
Yeah, and it looks like it's got little windows in it, so it's quite obvious. No, I'm sorry. I was going to say the Wyndham had that, but it did not. If you've seen the G5RV, Joe, those are usually made with window line as being part of the antenna. PRB, go ahead, please.
I just wanted to add, I use the term window line quite often and have had other hams come back to me and say, what is window line? Well, window line is what is commonly known to most hams, and it's quite different than ladder line. So a lot of people would call it ladder line rather than window line. But ladder line to me is different in a way that ladder line will have specific spacing between holes, and ladder line is typically used with I think, now correct me if I'm wrong, anybody, is used mostly with TV antennas, or then there's the 300 ohm line, there's 450, and that's typically window line, etc. But I just wanted to clarify that if anybody wonders what window line is, a lot of people call it ladder line, but it is a little different. Back to the net.
Yeah, functionally it's the same. take the standard 300 ohm twin lead and punch holes between the two wires. Now you got window line. It's the same thing, but a little less dielectric, a little less wind loading.
So
ASB comment?
Okay, we had a bunch of doubles here. So I'm just confirming, Dave. There are there separate window line and ladder line things there? Is that what you were saying, or were you just confirming that window line is similar to television twin lead, except for the impedance difference?
WIQ?
Stand by, WIQ. Dave, I think we must have lost you with the 7-5 timeout. I'm sorry. So we're waiting for a confirmation there for Phil and his comment. That's interesting comments there. ASP, you came first. Go ahead.
Yeah, okay, Kevin in the net. I mean, this may be a bit, too technical, but technically ladder line is an open wire feed line that has a cylindrical insulator that separates it every few inches or so. And typically the conductors are open wire. They're not insulated. And that's somewhat archaic, but back in the 50s and 60s, when you're dealing with kilowatts and megawatts of power, that was a very common feed line, and a very good feed line, and perhaps some of the lowest loss. The ladder line has coated wires, and the dielectric between the two is broken occasionally. And the 300 ohm or 600 ohm television twin lead has no break in the dielectric. W0ASP, back to net.
Yeah, you covered it, Terry. I hit a button and lost 7-5. Sorry. W0LEV. I'm going to go to supper.
Okay. Enjoy your hamburger, Dave. Thank you for being here. This is N7GES with the NCARC Tech Net. All right. Any other questions before we come back to Kerry? Okay, Kerry. Go ahead.
So many things in technology are often related to standard things, like the CLC pi filter resembles the mathematical symbol pi. Ladder line will resemble a flexible stepladder, so to speak, so that's why it's called ladder line. The window line, on the other hand, is put together with a solid dielectric with holes punched in it, the holes looking like a window. So that's how you can, what shall I say, separate the terminology. But on the other hand, it's just the way somebody viewed it as they were putting it together, so to speak. So, and any conductor carrying current has a magnetic field around it. And it's this magnetic field that couples to other conductors, whether it's in a transformer, in a feed line, whatever. So, I mean, hey, never can lose track of that magnetic field. And then it's the electromagnetic waves that are RF that we transmit from radio to radio. Hey, that's current with a magnetic field being transmitted through the air. Hey, it all comes back to some basic.
Okay, very good. There's a lot of other folks that have checked in here that we haven't heard from, and that is not unusual. But I just want to give everybody a chance to either make comments or ask questions. Do we have other questions about feed line, coax, hard line, window line, how to use them, what types to use? There are lots of different types of coax lines that we have access to. I know we've probably got other questions, so please feel free to ask.
N0 NYY.
NYY, go.
So I sense that there are a few newer people on this evening, and I wanted to, if I may, take a moment and discuss the loss in some of the various types of coax that we have talked about. I actually included a twin lead in the data because it was curiously considerably lower loss than any of the coaxes that were in the quick list that I brought up. Can I take a moment and go briefly over that?
Please do, and I do think this is very important.
Okay. So the biggest difference, these are all 50 ohm coax. I believe the twin lead is 50 ohm. I need to look that up to verify, but there is a variety of it that is 50 ohm available if the number that I picked is not specifically 50 ohm. RG8 was the half-inch kind of standard coax used by many people for most of their ham stations for a long time, way back. Most of the others, LMR 400, 9913, etc., are very similar in their loss to RG8. Berryflex is a little bit worse, and RG58, that little skinny quarter-inch stuff you see on your mag mounts, is horrendous in terms of loss. I will quantify that here in just a moment. If you have, and these losses vary with frequency, so I've done a 3-legged graph here. I did 10 megahertz just for discussion. I did 144 megahertz, and I did 440 megahertz. So your dB losses at each of those frequencies for RG8 is RG8 at 10 megahertz is 0.388 dB per 100 feet. At 144 megahertz, it goes to 1.54 dB per 100 feet. And at 440, it's 2.818 dB loss per 100 feet. Now, 3 dB, for the purpose of discussion, is cutting your signal in half. RG58 at 10 megahertz has 1.19 dB of loss per 100 feet. At 140 megahertz has 5 dB per 100 feet. And at 440, or UHF, it's 9.7 dB per 100 feet. As you can see, it's catastrophic for use on the 440 band at long distances. The 10 feet of it in your car for your mag mount antenna is not going to hurt too much, and it fits through the doorway really easily. That's why it's very common for mobile antennas. Radio Shack used to sell 100-foot rolls of it for doing your ham station. That's kind of a bad idea with RG58. There is more detail available on the graph, but I don't want to tie up the repeater for a long time going over it. Anyone is welcome to contact me afterwards. It's also very easy to look up loss calculators online, plug in the name of the coax, the frequency, the distance, boom, there's your effective output power after the coax loss. N0 NYY back to net.
Excellent. Thank you very much. And yeah, some good basic info there for choosing for choosing line. And I think the idea of knowing whether they're okay for short patch cables or longer cable runs, it was an important thing. Especially because I know I've seen radios that VHF, UHF radios that instead of having a connector in the body of the radio, actually have a piece of RG58 coming from the radio with a connector on the end. I've always wondered about that. Okay, thank you. Other comments or questions from anybody on the net here?
K0PRV.
Go ahead, PRB.
Oh, I want to say yes to Bart. I back up everything that he was mentioning. That's really cool, and it's good to know these charts, you know. And I just want to add some brief comments here to start with. Avoid adapters if possible, or when possible. You know, you can't always avoid adapters, but adapters can cause loss and SWR issues. I've had that. I've run into that a couple of times, and feed-throughs through the wall can cause problems, especially with the higher frequencies. Be careful. And understand what project you're working. So if you're starting a project, know the power, maximum power that's going to be used. Maybe in the future, think about that. You know, you may want to add an amplifier and such. So it's good to know that. Research, don't guess. Always research what's going on. So that's part of know your project. You need to understand that, hey, I'm going to have a line that's going to have 440 and 2 meters, etc. You need to know what line to use, and there are some basics to just get around. You don't have to always, you know, research if you're running short lengths or whatever. You know, consider. I'm going to reset. Consider that, okay, if I'm going to use 2 meters 440, think about LMR 400. Just think LMR 400 all the time, especially going out to your antenna. You know, 50 feet, 100 feet, doesn't matter. Velocity factor is a big thing as well. And so study up on velocity factor. It's good to know. Again, know your frequency, because your frequency and the type of line you use makes a big difference, especially when you start getting up above 6 meters, you know, into the higher frequencies, the type of connectors, etc. Short lines, like Bart mentioned, you don't, like in your automobile, most NMO mounts, if you use those, don't really like to accept the RG8X. The diameter's a little bit too big for them. So you end up using the RG58, but it's a short run, not a big deal. Reset again. And it was mentioned by Kerry, spend more, you know, if necessary or when necessary. Don't try to cut everything too cheap. If you do, you're going to end up with problems, and you may end up spending more money later on. Charts are all over the internet for cables, for the different coax. ARRL handbook, as Dave put it, use those. Always, you know, look up charts, understand the charts, because they'll show how much power, what your velocity factor is, etc. You know, your dielectric type, and those are all very, very important. So LMR 400 for UHF, VHF, I just use that right off for an outside antenna. RG213, RG8, those are pretty close to being the same thing for HF. You know, think about those. So RG8X, kind of in a pinch. You can use that in short runs and etc. Works okay for HF, but I would still go with RG213 just in case you're going to boost your power. That's all I have for right now. Back to the net. K0PRB.
IQ with another comment.
Yeah, stand by a minute, WIQ. So, thank you. Wow, lots of good info and recommendations. I appreciate that. So I don't have a chart in front of me right now, but I've heard comments about the RG8X before, not being nearly as advisable for various uses. What is it recommended for? Or what are the reasons for using it, let's say?
Is that question directed at me? K0PRB.
I'm sorry, yes, you, and then if anybody else wants to expound on it more.
Well, again, RG8X is just a smaller version of RG8. It's similar. RG8, you can use higher power, where RG8X is the lower power type cable. It has similar properties to RG8, but it's not recommended for long runs. You can still use it, like I said, for HF. Especially in a mobile, if you have HF, I would still try to use RG8X rather than the RG58, just for the heck of it. But that's just what I would do. But from what I understand and what I've read, the 8X is a smaller line, more loss, and the RG8 is a thicker line, higher power, less loss overall.
NYY.
Yeah, stand by, Kerry. NYY?
Yeah, RG8X and RG8M rank very, very close to the same. At 440, you're looking at 8 dB loss over 100 feet. Not a good option in terms of a long distance if you want to be efficient. Again, slightly better than RG58, slightly bigger. It's kind of one of those in-between things. If you happen to get a spool of it for dirt cheap, go ahead. In fact, that's a driving force for a lot of us is, am I going to spend $30 for a roll of coax or $300? And if I can get away with 30, I'll do the research and see and know what it's going to cost me. Okay, it's not as good as if I spent the $300. It all comes down to the dollars. So, and if you have any questions, again, open invitation. Contact me, contact Phil, contact Dave. Plan it out a little bit. You'll be really, really pleased with your results. And if you've got an idea, talk about it. Ask questions about it. You don't have to wait for the Tech Net. You could catch any of us anytime on this repeater. It's one of the things that I love about this repeater. N0NYY back to net.
Yeah, absolutely. Thank you, Bart. WIQ, go ahead.
Okay, Kevin, it's one of those things. Now, if you want to follow the power from your radio to the antenna, the radio has the maximum power. If the feed line loses 3 dB and the antenna has 3 dB of gain, it's a wash. The power from the radio goes to the antenna. But what can I say? Or the output of the antenna is a wash, I should say. But anyway, that's one thing. And I feel slighted when Bart didn't include me in the list of people that know things because, well, one, I used receivers and antennas as a way to earn a living for a lot of years. So how to make a transmitter, how to make a receiver, how to use feed line between the two things like that are things that I know by heart, so to speak. Back to Net.
Well, just to say that there's any number of people he could have included, and not to include everybody, is certainly not a possibility to include everybody, so I don't think you need to feel slighted about that. Anyway, other comments or questions for us here? We're getting sort of close to our closing time here, and we've covered a lot of things, but I still want to leave it open for anybody else to ask questions or make any additional comments.
N0 EMP.
EMP, go ahead.
Yeah, we've talked a lot tonight about transmission line loss and loss per 100 feet and the cost of buying much more expensive cable to mitigate that loss. And we've talked about how you have more loss at higher frequencies, VHF, UHF, and up into microwave. There's a couple things that can be done that become financially attractive at a certain point when you look at what length of feed line you would have from your operating position to your antenna, especially if you have a tower and a rotor and you're working the higher frequencies. One thing to do is for receive, you can have a preamp at the antenna which is powered by DC power going through the coax from your shack to provide power to the preamp. And there are versions of this preamp that switch out for transmit so that you can use it to transmit, and you still have your cable loss on transmit, but the preamp, which is at the antenna, switches out of line for transmit so it doesn't get damaged. And then when you unkey the mic, it goes back to act as a preamp for receive. So if you've got 9 dB of cable loss, but you've got a 9 dB preamp at the antenna, then you've made up for that loss. You can't have the preamp at the shack after you've already lost 9 dB of signal, because once you've lost it, it's gone. But that's one mitigating technique that can be used, and at a certain point that becomes financially attractive. I'll let this reset here. Another option, which is becoming easier and easier as we're having these network controllable radios, and we're getting radios with USB ports in the back and remote heads and things like that. At some point, it can become attractive to put the transceiver right at the antenna and not have a feed line, or have only a 12-inch feed line, and then, of course, in a waterproof enclosure and everything like that, and control it from your shack hundreds of feet away. That, again, at some point on some frequencies, and especially if you're doing weak signal work, that becomes attractive. A similar technique is to use what's called a transverter. A lot of people, if they're working 1.2 gigahertz or higher, or even 900 megahertz, they might use a VHF radio in the shack running 5 watts and a transverter at the antenna, which upconverts on transmit, upconverts your 144 megahertz signal to 1296, and then on receive, it downconverts that 1296 to 144 point whatever. So the RF that's on your coax is going to be VHF instead of that microwave frequency. So those are some things that can be done once you get, if you have to have a long cable run and you don't want to buy hardline, financially those things can become attractive at a certain point. And 0 EMP. Okay, excellent. Thank you.
This is N7GES in the NCARC Tech Net. Any other last comments or questions for the net regarding this subject?
W0ASP.
ASP, go ahead.
One type of cable that I did not hear amongst the discussions is the Times Microwave LMR 400 or 420, LMR 420. This is an in-between, this is about an eighth of an inch, a little bit bigger than RG58, but it has much superior loss characteristics compared to RG58. It is reasonably similar. You can take an SMA connector or a BNC connector quite easily, and it has much less loss than the traditional RG58, and it has all of the good design features of the LMR cable, being foam dielectric, foil, and braid. So that is something that people should consider. W0ASP.
Okay.
All right.
Okay, and Bart, just a second, yes. And I just want to confirm that was LMR 420, right?
Sorry, Kevin. LMR 240.
Okay, LMR 240. I wasn't sure if I was reading it wrong or had written it wrong, so thank you. NYY, go ahead.
That was my question, and I did just find it. I heard 420, and I was trying to find it, and that's what I wanted to clarify what the cable was. 240 is on my list, and I'll pull it up directly.
Sorry for the dyslexia.
Hey, did you know I've had Braille dyslexia many times. It happens. Sorry. Terry, do you happen to remember, is that what you gave Rick to make the 220 antennas, or was that something a bit different again?
Kevin, that is exactly what I gave Rick, and I believe that was the LMR 240 Delta Bravo, which is the direct burial. It is a bit stiffer than most of the 240s. There's also a LMR 240 Flex, which has the same electrical characteristics, but is a little bit more flexible, more akin to RG58. But I don't have the numbers here. I think Bart will enlighten us as to the numbers as to the LMR 240.
Okay, very good. Bart, were you going to do those now, or are you? Was that your plan?
Roger, I have it already. I'll do just a quick comparison at 440 megahertz and 100 feet. The worst cable in the world is RG58 at 9.7 dB. RG8M, the mini foam stuff, is 8.16 dB. LMR 240 that we just discussed is 5.2, and most of the RG8 varieties are 2.6 or 2.8. So it's almost twice the loss of the fat cable, but it's way better than RG58, so it's just in there. And again, these are commonly available, www.qsl.net, Charlie Oscar 8 Tango Whiskey coax calculator. If you put in coax calculator, it's like the second site you're going to see. and I chose it because they list like 50 different coaxes. Back to net.
Okay, and can you give the website one more time? I'm writing very, very fast and not getting everything here.
Roger. The website is whiskey.qsl.net/Charlie Oscar 8 Tango Whiskey /coax calculator. Coax _ calculator .htm Hotel Tango Mike.
Okay, excellent. Thank you very much. Good reference, and lots of others out there too. This is good stuff, and well worth paying attention to. So do hope we gave everybody some good info here, but especially beginners that are really wondering about all these variations and what on earth to go for there. So thank you all very much. One last call for any additional questions or comments.
K0PRB.
PRB, go ahead.
One more thing to throw into the mix that wasn't mentioned is stranded core versus solid core. So center conductor, stranded versus solid. Interesting information, other than one is more flexible than the other, stranded being more flexible than solid. Are there any other advantages or disadvantages?
NYY.
NYY, go ahead.
That's a very good point Phil brings up. Thank you, Phil. If you are hanging coax down the side of your tower, you will prefer solid core. It has a much lower stretch factor for a given amount of weight than stranded. Yes, it is much less flexible. If you use solid core from the top of the tower around the stem up to your rotator, you can last about a season, and you'll be replacing it. Whereas if you use stranded up there, it'll last quite a bit longer. And stranded will have variations over time in its impedance if it's hanging down the side of the tower. So solid if it's going to be still, stranded if it's going to move. Stranded holds the weight a lot better than solid does, but you're talking about 5, 10, 15 years of gradual creep in the impedance. And I think you will see that on 440. You would definitely see that on higher frequencies when you get up into the gigahertz range. The difference could be huge. Something to think about. I have no experience running stranded down the side of the tower. I know in past applications it stretches and changes a little bit, but I really can't quantify that.
Okay. Any other comments on this last question? Okay. Then I think we'll close it for this evening. Thank you all very much for your comments. I'm trying to get to my list of topics here to see what I had chosen for next week. So I'll be there in just a moment. How about which HF bands to use and when to use them? We have lots of band choices. They vary in, of course, frequency. They vary in their propagational properties, by times of day, and various other things. For folks that are brand new, this could be very valuable. For some of us that have been on for a long time, it could be very good reminders. So if everybody's agreeable to that, or if anybody wants to make any comments, not about the topic, but about their comments on my on that being a good choice or otherwise, I'm open to comments right at this point. Well, in this case, I'm hoping silence is golden. It usually has been. I thank everybody for their participation, their patience, and their attentiveness, and all the contributions, too. We'll be here next week with our new topic. If you would like to make comments about the net or have questions that you'd like addressed on the net, please address those to Elmers at NCARC.net, ELMERS, at NCARC.net, and let us know what those are. You can always make comments on the video stream, and those get back to us as well. So again, thank you, 73 to all. And I'm going to return the frequency to normal use, wishing all of you a very, very good evening and a good week. This is N7GES, clear.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.